Welcome from the Biomeda Water Management Project at the Marion Pump Station here in Scott, Arkansas. I'm Lee Riley with the University of Arkansas System Division of Agriculture, and we are excited that you joined us for our 4th virtual field trip in the Soil and Water Conservation Series funded by NRCS and hosted by the University of Arkansas System Division of Agriculture. So to get us started, we're going to talk about the equipment you see behind us here. The machines are all big electric pumps for moving water from the Arkansas River to farms in the Biomeda irrigation area. Joining me to tell us about the pumping station is Ed Swaim, Executive Director from the Biomeda Irrigation District. Ed?
Thanks, Lee. Thanks for being here. This is the Marion Pump Station at Scott, Arkansas, and we have 6 pumps and 6 large electric motors. The big electric motors are 1,500 horsepower apiece, and the smaller ones are 450 horsepower. When this project comes online, we'll pump water from the Arkansas River, which is about a quarter of a mile that direction, out into a regulating reservoir, into canals, and then down bayous to farms in the Delta and Grand Prairie.
Thanks, Ed. We're going to hear a little more from Ed in just a bit. But first, let's discuss why this project is so important to water conservation and the conservation practices on farm for conserving water. Today's virtual field trip, we're going to cover groundwater and aquifer issues, conservation practices to conserve water. We're going to hear from our Arkansas Discovery farmers near Stuttgart, Lori, Terry, and Trent Dabbs, and how they're reducing water and reducing their water usage and storing water on their farm. And we'll hear again from Ed a little later on about the irrigation district, the alluvial aquifer, and the critical groundwater areas. So what is groundwater? It's difficult to visualize water underground sometimes. We're typically not talking about lakes or streams that are underground flowing. Groundwater is simply subsurface water that is saturating cracks and pores in the soil and rock. Groundwater is replenished by precipitation, rainfall, snow melt, water that doesn't evaporate, collect in streams, or is used by plants, infiltrates into the soil and becomes groundwater. Water in the upper layer of the soil we call the unsaturated zone. This is where water is typically used by plants. Now, this zone can be saturated after significant rainfalls, but you'll usually have to dig down a little ways to find sufficient water. And the saturated zone is where you'll find what most people refer to as the water table. So all openings and crevices, pores in the soil and rocks underground are saturated with water. In this next slide, we'll see an example of aquifers. Groundwater flows into the soil, into the subsoil surface at different rates. We have confined and unconfined aquifers. Your upper unconfined aquifers are typically where you're going to find your water table. And they'll all be recharged from that precipitation at different rates. So if you've got several confining layers of rock or clay, it can take a significant amount of time, decades to centuries and even millennia, the deeper the aquifers and the more confining areas there are. In the more porous areas, the unconfined aquifers are going to recharge quicker. So with multiple confining layers, it's going to take a long time to recharge, so you can see why we'd be so concerned about how long it takes to recharge them and pumping water out quicker than Mother Nature can recharge them. This next slide, the area that we're discussing is the Mississippi River Valley alluvial aquifer. We're focusing on the region shown in the red there. This is the shallowest aquifer in the Mississippi River Valley system, or aquifers. It's typically used for irrigation. We also have the Sparta aquifer that is deeper than the alluvial, but the alluvial is 32,000 square miles in 7 states. The major rivers that are in this aquifer system are the Mississippi, of course, and then we have the St. Francis, White, Arkansas, the Yazoo, and Ouachita. So speaking of irrigation, we use a lot of water to irrigate crops in Arkansas. And this first slide you'll see is a picture of a fairly typical electric pump. This is used for sucking water out of those aquifers, out of that groundwater that's used for irrigation. In this next image, you'll see water being pumped into a rice paddy. Arkansas grows a lot of rice. We're #1 rice producer in the U.S., producing nearly 50% of the rice in the U.S. And traditional rice production uses a lot of water for flooding fields, maintaining a shallow flood to control weeds. This next image, you may have seen these large structures in some agricultural row crop fields. These are center pivots. These pivot around a water source, drive in a circle and simulate rainfall as irrigation. And what's becoming more and more common in this next image is lay flat polytubing that's rolled out along the edge of a field. It fills up like a balloon with water. You poke holes in it and water streams out of the holes and runs down the furrows. In this next slide, some data compiled from the USDA's irrigation report over the years. You'll notice that in Arkansas, acreage in farms has decreased some. Now this is all farm acreage. This is not just row crops. This includes all farm acreage. But even as the acreage of farming has decreased, you'll notice that blue bars, irrigation, has increased quite a bit over the years. And continuing with the data from the 2017 USDA irrigation report, you'll see that we irrigate 58 million acres in the United States. Arkansas is #3 in irrigated acreage with 4.8 million. California and Nebraska are 7.8 and 8.6 million respectively. The states, 8 states compose 36.3 million irrigated acres, while all others combined are 21.6 million. Next, we'll get into well, here's some data about the 2018 Irrigation Management Survey and acre feet applied. Ed's going to get into that in a little more detail a little later on. This cone of depression is what we're concerned about. And cone of depression is not something your dog wears when he's sad. So this is a groundwater that is being used quicker than can be replenished. So irrigation isn't the only user of groundwater. There are power plants, domestic and commercial wells. Some of you may have wells at your homes. Mining, industrial use. But irrigation accounts for 80% of freshwater consumption. And a lot of it is lost to evaporation, and what's not used by plants sometimes will run off in less efficient systems. 25% of fresh water in the U.S. is from groundwater, and 43% of that water is used for irrigation. This graphic shows that shallower aquifers and those that are permeable enough and can flow well enough can actually move water through them via wells, discharging them quicker than Mother Nature can refill them. So you can see why this could be a problem. Next, we'll talk about this next slide. We'll talk about the depth to water issues that we're having. This map shows several counties with cones of depression in Arkansas. The darker orange and red, the deeper the water is. Groundwater is too deep to cost effectively pump at the volume needed to produce conventional row crops. This red star, that's what will pop up here, shows where the Dabbs farm is located and why this is an issue for them. The water is too deep for them to cost effectively irrigate their farms. Next, you've probably seen various slides similar to this. Population's ever growing. We're expected 10 billion people by 2050. Water's a serious concern. We all need water to produce crops and to survive, because we've all got to eat. We all have to eat. And in this final slide I'll show you here, the water issue is not just an Arkansas problem. There are most of those 8 states that I showed you in the pie chart earlier all have groundwater availability issues. So we've got to do something to conserve our water, because it is not an unlimited resource. Next, we're going to hear from Ms. Lori Dabbs. It's going to talk a little bit about the history of their farm and what got them into wanting to conserve water on their farm. Ms. Lori?
Good morning. Thanks for having us here today, Lee. We appreciate the opportunity to be a participant today and also to be partners in the Arkansas Discovery Farm program. I'm here to give you some firsthand info of how important water is to our farm and our family. I'm going to open our part of the presentation by giving you a background of our water situation and why we are where we are at today. This first slide shows my family's why. With my great-grandfather, my grandfather, and my father, it was all about the following generations. My sisters and I were their why when it came to purchasing and then leaving the farm to the next generation. Over the years, we've progressed from this to this. Trent will get into more technology and how we got from one place to the other, but it's not a simple get on a tractor, plant the crop, harvest the crop anymore. My great-grandparents brought our family farm that we're on today back in the mid-40s. It had a mixture of groundwater and surface water at that time. We had 3 shallow wells, the alluvial wells that Lee spoke of, 2 connected reservoirs, 1 other reservoir, and 1 deep well, Sparta well, that Lee also mentioned. The water was distributed to the fields via a canal system. You see it in this slide behind the house. That was part of our canal system at the time. Approximately 2 miles of canal went from the reservoir to the far eastern end of the farm. The 3 shallow wells were used mainly as supplemental water for our rice crop and to irrigate soybeans. The last of those wells quit producing sometime in the early 70s. That left us with a dilemma, an inadequate water supply to meet our in-crop demands. Rice was our cash crop, so that was irrigated first and foremost. I can remember my dad used the 4th of July as his benchmark. He could tell by looking at the reservoir levels on that date if he had enough water to finish out the rice crop and if there would be any excess to irrigate the soybeans. So this is where the why kicked back in. Why should we take the steps needed to meet our water needs? Why should we look at alternative crops? Why should we install conservation measures to enhance our farm? And for my grandfather and dad, it came back to preserving our farm and resources for my generation and generations to come. In the late 80s, we put a plan in place to install improvements to our farm. We brought in dirt pans, which you see in this slide, and very methodically began the process of leveling our farm. We had a plan in place to level 3 fields per year. Only 1 of our fields is 0 graded and the rest have straight levees. By the mid-90s, we were well on our way to being more efficient in our irrigation practices. Did that solve our inadequate water supply? No, but it was definitely helping. This slide shows a layout, an aerial view of our farm. And it also shows the improvements that we made during the on-farm component of the Grand Prairie Area Demonstration Project. The project had 2 components, and we signed up to further our conservation plan with updating our irrigation system. Project 1 involved closing in the 2 miles of canals and installing pipelines. In the picture you see, the green lines indicate the new pipelines that were installed. We also installed a tailwater ditch, and at this point we were capturing all normal runoff on our farm. You'll see the red lines in the picture. send all the water back to the reservoir, which is on the left end of the picture. The cost share was at 65%, so for a total cost of the project of $306,000, our out-of-pocket was just over $107,000. The project was spread over 5 years and was completed in 2005. We took advantage of the state tax credit and were able to use $54,000 as a tax credit. This part of the farm was irrigated mainly by a Sparta well, and I'm looking now at the part of the farm on the right of the screen where you see the green X. The Sparta well that irrigated that part of the farm was constructed and dug in 1954. Total depth was 884 feet. The static water level was at 171 feet, and that was in '99. According to the research that's being done now, the water level has dropped significantly. At one point, it cost us as much to irrigate the little square down on the right end of the picture as it did the big rectangle, the main part of our farm. That was about 300 acres versus 1,200 acres, and it cost us more to irrigate the 300 acres than it did to irrigate the rest of the 1,200 acres. So when we converted to surface water, cost savings was a big advantage to that. While this farm had a small reservoir on it, it wasn't designed so much for irrigation as it was for recreation. Another advantage of surface water we found was the recreational aspects that it does and wildlife benefits that it provides. So then contract number 2 under the Grand Prairie project. Under this contract, we were able to add a 30-acre reservoir on that farm and update all of the old pipelines. While we left the deep well in the connections, it is now only used as a backup and to pump up the reservoirs if needed. We also added a tailwater ditch on this part of the farm and then tied all of the water sources together. We're able to move water in both directions and can now adequately irrigate the farm under our normal crop rotation. This project had a total cost of $210,000 and our out-of-pocket was approximately $74,000. Again, we were able to utilize the state tax credit and that amounted to a $37,000 tax credit. This project was completed in '02. At this point, we were adapting to these improvements, but we were still seeing hurdles in irrigating all acreage completely. It was still a strategic game to making sure we had enough water to see our crops to fruition. We were still using my dad's strategy of gauging remaining water in the reservoir on the 4th of July. We added milo to our rotation and also corn. We still weren't able to operate the system to our full advantage, and we were looking for affordable alternatives. The water might have been in the reservoir, but due to system design, we weren't able to efficiently get it to where and when we needed it. When our watershed was added to the Mississippi River Basin Initiative through the EQIP program, we sat down with NRCS engineers and played what if. After looking at several scenarios, several of which were cost prohibitive and several were environmentally unfeasible, we settled on a plan to add surface water storage and additional pipelines to service about 300 acres. In doing this, we finally have a system in place that we feel comes close to optimizing our acreage. We built up the levee around an existing overflow area, and in doing so, we added about 450 acre-feet of storage. We also tied all of these pipelines into our existing system, and we're now able to move water from the tailwater ditch back to the older reservoir or to the new reservoir. Likewise, water from the new reservoir can go into our Main Street pipeline to be sent to wherever it's needed. This project was funded a little differently than the 2 previous projects. This contract through NRCS had maximum payouts on each item and a schedule of government cost share. The total cost on this project was $262,000. However, the dirt work on the new reservoir was capped out at $131,000, and we had non-covered expenses in work to retrofit the existing overflow area, so our out-of-pocket on contract items was over $120,000. And then we had the additional expense in the prep work that wasn't covered under the contract. Our next project at some point will be to retrofit the reservoir that you'll see in this slide. It's silted in, the banks are deteriorating. We want to be able to more effectively manage it, not only for irrigation, but also for waterfowl management. Also, in the back of our minds, we know that major work will have to happen at some point on the main body of our reservoir, waiting on the right time and the right program to come along, just to be able to accomplish this. In looking at our use of surface water, there's many advantages. We didn't have a choice on this farm because groundwater was not an option. You remember I pointed out that the 3 shallow wells that we had at one time quit producing in the 70s. Sparta well is not cost efficient. So there was really no choice but to develop the surface water. It was not based on the advantages, but rather the lack of groundwater that drove our decisions. However, we did find that there are advantages. The costs that I mentioned, environmental sustainability, recreation benefits, wildlife, aquatic benefits, no cold water shock or salinity problems. We also increased our production, specifically in our soybean yields, and even though we took land out of production, we still saw our yields increase as a whole. We also have VFDs, which Trent will discuss later, that are more efficient in timeliness and volume, and we're also able to cut our irrigation labor. On another farm, groundwater is plentiful, merely 7 miles away. The water's shallow, it's cheap, so why do we develop the surface water on this farm as well? Because groundwater is shown to be declining. It doesn't appear to be a sustainable resource. It's the right thing to do along with the reasons I mentioned earlier. It goes back to my why. The same as the why of my grandfather and father and great-grandfather, this is my why. It's our responsibility to leave sustainable resources and farming practices for generations that follow us. This last slide is one of my favorites. It's a perfect sunset, one of my favorite places on our farm. It's a place of peacefulness, solitude, and it serves to remind me that at one time I was someone's reason why, and it's now up to us to continue the process.
Thank you, Ms. Laurie. Up next, we've got Terry Dabbs. He's going to talk to us a little bit about the reservoirs and tailwater recovery system they have on their farm, as well as a little info about their role as a member of the Arkansas Discovery Farm Program. Terry?
Thank you, Lee. Appreciate the opportunity to be here today. As you heard Laurie talk about earlier, you heard the mention of reservoirs a lot. And the slides you're looking at now is just a picture of what we call our big reservoir. And on this farm, we have a total of 5 reservoirs ranging in size from 10 acres to 450 acres. And a reservoir is just simply a place to store water. All the reservoirs are man-made. Some people look at it and call it a lake. Some might call it a pond. But reservoir is just a common term that farmers use to describe where they store their water to keep in for their irrigation purposes. Also, you heard Laurie mention some things about cost share programs, and reservoirs are extremely expensive to build in today's time. This particular reservoir was built in the 30s, built with drag lines, and built in low areas of the farm that were not productive for crops. So the cost share program is very important, not only to the farmer. Yes, the farmer gets a benefit out of using cost share programs, but it's also a great benefit to the general public, because the more surface water we develop just means that's the less amount of water we're going to pump from groundwater. And the groundwater is what your cities, towns, municipalities are all using for the drinking water. So the more surface water we can use, it's just a win-win situation for everybody. Managing in a reservoir is no different from managing anything else on your farm, the crops you're growing or anything else. You've got to stay on top of it so you have an adequate water supply when your crop needs it. So the way we do, and the slides you're looking at now is just an example of filling a reservoir. To the left is a pumping station. There's a ditch or a bio stream, whatever, that runs beside the reservoir, and we pump water out of it into the reservoir. We usually do this process in the wintertime, January, February time frame, when there's a lot of excess water in those ditches, and that gives us an opportunity to get the reservoir full and get it ready for the farming season. So then once we get the reservoir full and it comes irrigation season, we got to have a way to get the water from the reservoir to the farm. And a lot of our fields are a mile, mile and a half away from the reservoir. So to do this, you heard Lori mention, originally it was a canal system. We converted it to an underground pipe system. So we have large plastic pipes buried underground that we pump the water into. And so on the other side of the reservoir from where the water was pumped in, we have 2 pumping plants that pump water out into these pipe systems. We have one 6,000 gallon a minute pump with a 200 horsepower electric motor on it, pumping into a 21-inch pipeline. We have another system that's a 75 horsepower motor that pumps 4,000 gallons a minute into an 18-inch pipeline. And then these pipelines intertwine across the farm, connect with each other, and go to each field. So the slide you're looking at now is what we call a riser. There's one of these that comes up in each field, and that's how we deliver the water to that particular location when we need it. Other things that we use on the farm to deliver water, this is just a slide showing an example of polytubing stretched across a rice field in a multiple inlet situation, where we're letting water out into each levee instead of pumping it into the top paddy and gravity flowing across the field. This has been a good conservation measure for us. We've saved water using this process. This slide you're looking at is just a slide of watering soybeans using polytubing again. And then this same process would work in a cornfield. So every crop we grow, whether it's rice, corn, soybeans, it must be irrigated. Even though in Arkansas we get over 50 inches of rainfall a year, it usually falls at the wrong time that when the crop needs it. We get a lot of rainfall in the wintertime. As I mentioned earlier, that's why we fill the reservoirs up then to store the water. And then when the crop needs the water, then we have the water available for irrigation. We have a big focus on our farm on water. You know, that's what this is about today, is water and water conservation. And we talk about water all the time, ways we can conserve our water and use it more efficiently. And we're also concerned not only about the quantity of water we have, but the quality of water we have, because water is the lifeblood of agriculture in eastern Arkansas. We cannot farm in eastern Arkansas without water. Another thing we've done to supplement this is built what's called a tailwater recovery system. That's the slide you're looking at now, is just a view of our tailwater system. It's just a large ditch that you dig in an area of the farm where you can get drainage off of as many fields as possible. You see those 2 white pipes there, that's just where the water comes into the ditch that's draining off of a field. And that could be water from when we irrigated and we had a little excess water, it drained back into this ditch. It could be rainfall water that we captured into this ditch. Once we get it in this ditch, then there's a pumping plant at the end of the ditch, and we have the capability of either putting that water back on the field, irrigating with it, or we can pump it back to the reservoirs and store the water in those reservoirs until we need it. So the farm also has a drainage ditch that goes all the way around it that goes back to the reservoir. So this particular block of the farm, we can capture every drop of water that falls on it, that we pump on it. No matter how that drop of water gets on that farm, we have the capability of reusing it, storing it for future use. The other thing we got involved in a few years ago was the Discovery Farm program. This is a program that was initiated by a group of farmers and the University of Arkansas, along with Arkansas Farm Bureau and some other sponsors. that we needed something like this in Arkansas. And what it is a system of sampling the water, doing what we call edge of field monitoring, and in some cases whole farm monitoring, to see what the quality of the water is that is leaving our farm. There was some things going around, and agriculture and farmers were getting accused of things such as the hypoxia in the Gulf, the dead zone in the Gulf of Mexico. People were saying that farmers were just using too much fertilizer and it was running off their fields and getting into the rivers and going to the Gulf. So we didn't believe this was really the case, so we wanted some way that we could see if we could dispel this rumor or prove otherwise. So this program monitors water that comes off of a farmer's field. And it doesn't matter if it's rainwater, if it's irrigation water. If the water comes off the field, there's an automatic sampler inside this box that takes a sample of that water when it runs off. And then that water is collected by personnel from the University of Arkansas. The farmer has nothing to do with it, never sees it. It goes to an independent lab to be analyzed, and then the university gets the results back, and we determine what was in the water. Main focus when we started the program was to check for phosphorus, nitrogen, and settlement. The program has been very successful. We have learned that farmers are doing a really good job of controlling the nutrients that is leaving their farm. I believe the results that came back showed we were losing less than a pound of phosphorus, which is a very minute amount getting into the water system. So, like I said, we're also concerned, especially on this farm, about the quality of our water. Since we're capturing our water and reusing all of it, we wanted to be sure that there wasn't anything in the water that we were storing that we were going to come back on our pump back on our crop that'd be a detriment to us. As far as our goals for the future, our goal is always to constantly look at new ways of irrigation, ways to become more efficient, sustainable, and as well as a cost saving to us. We also, as Lori mentioned, we're going to have to keep doing maintenance on our reservoirs, do levee work, keep them maintained and in good shape, maybe even have the capability of storing more water. We're constantly looking, there's new technology coming out every day to help us. There's all kinds of moisture sensors, database, just all kinds of information available. That's changing on a daily basis, and we're always looking at technology to help us in the future. Thank you, and I appreciate you joining us today.
Thank you, Terry. Up next, we're going to have Trent Dabbs. He's going to talk a little bit more in depth about that technology that Terry was telling us about and conservation practices that they've implemented to conserve water on their farm. Trent?
Well, thank you, Lee. I appreciate the opportunity to be here with you today. And like I said, I'm going to talk about a little bit about the production practices and some of the technology we're using to achieve that water conservation. So we'll talk about a rice situation, and you've heard a lot about land leveling already today. So what we talk about there is in a typical rice field, you'll notice the levees are very curved and follow the contours of the land, and that's usually on a 2/10 of a foot drop. So when we go to precision level, as you'll see on the screen, the levees become much straighter. They're a certain distance apart based on how much fall you want in that field. And we're able to move that water to a spot on the corner of the field or lower end of the field where we're able to recover it in those tailwater ditches and then recycle that water and use it again. Some of the things that this helps us accomplish is it definitely reduces our labor that's needed to check all those levees and make sure there's no holes in those levees and patch them, and also water savings of being able to get the water on and off the fields faster. The next thing that we'll talk about is a zero grade project, and we have one of those on our fields. And you'll see there in the slide that there's no levees in this field. It is perfectly level from one end to the other. We would dig a ditch all the way around the border of that field that would allow for drainage. And then, like I said, it once again goes back into our reservoirs and our tailwater recovery systems so we're able to recycle that water. And when we talk about a flood on rice, a lot of people, I get asked a lot about how deep are you talking about. We're not talking about very deep floods. We're only talking about a 4-inch depth. And the reason rice has always been flooded was to control weeds. But with new seed technologies and herbicide technologies, we're now allowed or able to do some different things such as row rice. And that is just being able to grow rice on beds like we do in a soybean or corn production system. And some of the things that allows us to do is a lot less labor. It helps us save water. We don't have to pump as much because we're basically just trying to saturate the ground and not keep a flood. It's also a lot less stressful in our equipment and allows us to do minimal or no-till practices in the fall or the next spring to plant our next year's crops. And one of the other benefits that it allows is a reduction in greenhouse gas emissions such as methane. So a flooded system, whether it be a swamp or a rice field, produces methane. And when we're taking away that flood and just saturating the ground and keeping it wet, that allows for a dramatic reduction in those greenhouse gases. Even in a levee system now, we are doing a different practice called alternate wetting and drying that also allows for those greenhouse gas reductions. So what we're doing there is we'll flood the field for a little while, we'll pull that flood off, let the field dry up, not to a point where it's completely dry, but just sort of muddy, and then we'll flood that back up again. So that reduces the amount of water we're holding and pumping on that field, and like I said, reduces those greenhouse gas reductions as well. Even with all the land leveling that we did, we were still having issues with the amount of rice we were growing. At the end of the year, we were still running out of water sometimes in very dry years, and our soybean crop was still suffering. We had already put all our inputs into the rice crop, so we wanted to make sure that crop finished out, and we knew that needed the most water, so that's why we had to stop some waterings on soybeans and knew we had to do something there to fix that. So one of the main things we did was added corn to our rotation. We reduced our rice acres, and that allowed us to reduce also the water needs that we needed as we were able to catch some spring rains and help that corn crop along. I'll kind of switch now and talk about some of the technology that we've added on our farm to achieve those water savings measures and conservation. So one of the first things we did was change the majority of our diesel power units over to electric motors. That allowed us a tremendous savings in energy use and able to also use our water more efficiently. So you'll see an example there. That is the main pump out of our reservoir. That pump will pump 6,000 gallons a minute. But one of the issues with electric motors is once you start them, they're running wide open and they're on. So in the last few years, variable frequency drives, which is what is in that white box on the photo there, what that does is it allows us to be able to slow the motor down with a dial and be able to fine-tune the amount of RPMs that we're running to pump the exact amount of water that we need. Because there's times in the beginning of the year where we may only be needing to water a field or two, and 6,000 gallons a minute in one field is not very efficient. We may only need 1,000 to 2,000 gallons. So this allowed us to do that using those variable frequency drives, and also it saves tremendously on the energy use that we're using. Those pumps now are completely automated. Once I set the pump to auto, I'm able to control that pump from my cell phone anywhere I'm at, basically using just a simple text message system with using prompts like set speed or start stop or check status. We're able to see how long that pump's been running and what's going on with it. Some of the new things that have come out too to help with, you saw some examples of the polytubing that we are using. We use a program through Delta Plastics that's called Pipe Planner, and we input a lot of information into this program that helps us be able to choose the hole size that we need to most efficiently water that field. Where this really shines is fields that aren't square, fields that are maybe a triangle shape or have a wood line that's not straight. Before we started using this program, we would have the shorter rows would always water out faster than the longer ones, and we'd flood the bottom of the field, so we were basically wasting water that we didn't need to. Now we're able to input all that, the row lengths, the amount of water we have, and make those fields water out uniformly so we're conserving water and not over pumping just to finish out the field. The last thing I'll touch on is in some new technology or moisture sensors. And you know, Lori mentioned that we always just kind of flew by the seat of our pants, for lack of better terms, on when we needed to irrigate and use our water. But now with all the new technology and moisture sensors, we are able to know exactly what that crop needs when it needs it. So these are basically little small probes that are drilled into the ground in a hole, and they are set at 6-inch depths, so 6, 12, 18, up to 24 inches deep. Sensors are on those and allow us to know exactly how much water that crop is uptaking and when we need to irrigate. So Lee, I appreciate being here today and hope everybody enjoyed our presentation.
Thank you, Trent. Up next, we've got Ed Swaim. You heard from him earlier on. He's going to talk to us a little bit more about the Biomeda Irrigation District and what's going on here with the critical groundwater.
Thank you, Lee. Welcome to the Marion Pump Station near the Arkansas River in Scott, Arkansas. This station will pump water from the Arkansas River to farms east of here in the Delta and Grand Prairie. The pump station was finished in 2015, but the distribution system is still being constructed, so this station is not pumping water yet. East Arkansas is where we grow our irrigated crops. Agriculture is our #1 industry, and the health of the state's economy depends on it. Our project is located just east of North Little Rock in Pulaski, Lone Oak, Prairie, Jefferson, and Arkansas counties. Irrigated agriculture is Arkansas's #1 water use. Most, 85% of our irrigation water comes from the alluvial and to a lesser extent the Sparta aquifer. On average, rice uses the most water at about 3 feet per year. Corn uses 1.5 feet, and soybeans and cotton use about 15 to 16 inches. The alluvial aquifer, where most of this water comes from, is a layer of gravel and sand that produces a very large amount of water for irrigation. In the 100 years or so that we've irrigated, though, we've drawn the aquifer down significantly. The yellow area on this slide shows the unsaturated part of the alluvial aquifer, and the light blue area is still saturated. That purple line shows the saturated line as of 1965. As you can see, it has declined since then. Our goal is to deliver water to farms so they can reduce groundwater pumping to sustainable levels. If we can keep about 50% saturation in that aquifer, we'll ensure that it will never run out. Because we're talking about very large quantities of water, we measure irrigation in acre feet. 1 acre covered by 1 foot of water is 1 acre foot of water. That is 325,850 gallons or 43,560 cubic feet of water. By the 1930s, it was clear that we could pump more water from the ground than nature could replace. Studies recommended using our large rivers, such as the Arkansas and White, as sources of irrigation water. Groundwater pumping increased dramatically since the 1930s, and groundwater depletion accelerated. The Arkansas Water Plan projects that by the middle of the century, we'll need to pump nearly 10 million acre-feet of groundwater per year, but the sustainable yield of our aquifers is around 2 million acre-feet per year. That's an 80% supply and demand gap. People ask whether pumping from our rivers will draw them down, but state law protects property rights of people who have land on our rivers, navigation, aquifer recharge, interstate agreements, fish and wildlife, and water quality. Irrigation projects are limited by law to a very small amount of the annual flow of our rivers. During extreme low flow periods, we would have to reduce pumping. Our irrigation system starts with the Arkansas River that you see on this slide. This pumping plant is the brown rectangle at the top, and we'll pump the water from the river into a 40-acre reservoir just outside. Then it will travel through canals to natural bayous, such as Indian Bayou, to the east of here. These bayous will carry water to farms that lie along them, and with the help of the Natural Resources Conservation Service, we will also construct many miles of pipelines from those canals and bayous to farms. Bringing this water to farmland is essential. The alluvial aquifer in our project area is well below 50% saturated thickness, with some areas in the 10 to 20% range, as you can see on this slide. Likewise, in the Grand Prairie Area Demonstration Project area, where the Dabbs farm is mostly below 50% saturated thickness. As they describe, some large parts are effectively dried out. We know we are running out of groundwater, and we know that we can solve the problem by using the abundant surface water from our rivers. It depends on our finding the resources to finish construction of our 2 irrigation projects.
Thank you, Ed. Thanks to all of our speakers. Next, we're going to invite everybody back in front of the camera and attempt to answer any questions that our audience might have. So, about how long have you guys had reservoirs?
The reservoir on our farm was built in 1931, and it was actually the second reservoir built on the Grand Prairie. So we've been operating, when we bought the farm in the 40s, it was in existence, but like I say, reservoirs have been operating on the Grand Prairie for years.
And since 2000, we've added 2 new reservoirs.
Ed, about how far are we from, you think, getting the pump station up and running?
It's going to take construction of about 3 more miles of canal to get to Indian Bayou, the first natural stream that we'll reach. We also have to do clean out on that bayou and the ones south of it so that we don't induce flooding. We also need to build pipelines to reach the farms that aren't located right next to the bayou. Under our current plans, looking at the construction periods and contracting periods, it would probably take us about 5 years to 6 years to get water to the first farms.
How about some other conservation practices? Is anything else that's been implemented on your farms?
Well, like I said, I think with the being able to do row rice, that's tremendously reduced the amount of tillage we're needing to do in the fall and even in the spring. So no-till is definitely something we're kind of moving into. Cover crops is something we've looked at. We haven't jumped into that yet, but I think that's something that we probably will try in the future.
So, a question from our audience: if you poke a hole in the poly pipe, can you reseal it?
Not very easily. No, that's why we use those computer programs to help us know we have just a poker. I mean, it's no better way to describe it, that has different size kind of plugs that we can use that we poke the holes with. We do have issues during the year with animals stepping in the poly tubing and creating a hole, and there have been kind of like sleeves that we can put over to patch that. Gatorade bottles usually come in good too. You don't ever throw a Gatorade bottle away because they're good at sticking in and patching the hole, I guess.
General question for anybody that wants to answer it. So we had some flood events in 19, 18 as well. Do they benefit filling the reservoirs or perhaps providing water to farmers? Or is it more damage from flood than not?
Well, one thing I didn't mention was, we're constantly wanting to recharge the reservoir. So once we start taking water out of it in the summertime for irrigation, after we get it pumped down, anytime we can hold more water and we get a large rain event, we're still putting water back in it year-round if the water's available. So the flood events of last year, I wouldn't say they helped any. They may have actually hurt a little bit because our reservoirs actually got so full, water ran over the top of the levees. We couldn't get, at that point we were wanting to get rid of water, which is something we usually don't want to do.
You know, we mentioned that we capture all runoff from our farm and it flows back into the reservoir via ditches around the farm. But we also have a power unit, a relift in the bayou that runs past the farm. So if we need to recharge from the bayou, we have the ability to do that as well as capturing the runoff from the farm.
Well, one of the other things, you mentioned the floods, the last 3 years, we haven't had to start those pumps. Just the amount of runoff we've got from the farm running back has recharged those reservoirs during the winter, so we haven't had to hardly pump any water in. But like my dad mentioned, it was a problem last year. were too full and water was running over, and we had to actually start pumps to pump water off. So that's not a common occurrence, but it's kind of twofold there.
Yeah, I think we averaged 14 inches more rainfall last year than is normal for the state, so it's a lot of rainfall. Another question from the audience, how long have the Dabs been farming?
Who wants to go first?
You want me to? I think this will be my 48th crop. So our family has been in farming for over 100 years.
Yeah, so I grew up on the farm and actually came back and officially started farming, I guess, when I graduated college in 2001, so 19 years, I guess.
Okay. We had a question about education. What, if any, does our panel have to get them where they are and to know what they know about what they're doing? Whoever wants to go.
Ed?
Well, oddly, I went to law school, so and now I'm trying to get this project going. But that's helped me a lot. I worked for our state Natural Resources Commission for 20 some odd years and worked on this project as well as the White River project. Got a lot of experience with groundwater issues, with financing projects, with dealing with federal agencies and state agencies on resource issues, environmental issues. So it all helps to do the multifaceted work here to get this project built.
Okay. Anybody else?
I attended the University of Arkansas, majored in ag business, but as far as experience on these things, it's just nothing like everyday experience on the farm. Most of the things that we're doing, we didn't learn in college. We learned them on the farm, doing them every day.
Yeah, I went to Mississippi State and graduated with a degree in ag engineering technology and business, so kind of a dual major. So when I was there, GPS in agriculture was just blooming, so got to take a lot of classes in that, so that kind of got me interested in all this technology side of the business. So that's what I've used to help with that.
Interesting.
And I have a Bachelor of Business Administration from the University of Arkansas at Monticello, but I second what Terry said. Most of what we do comes through our everyday life experience. I was involved with the White River Irrigation District project for over 15 years. It made me realize that what we are doing is all that much more important.
We had another question about nutrient runoff on the farm. Terry or any of the Dabs, would you guys like to talk about that? Or would you like me to talk a little bit about the Discovery Farm program and what we found, whatever?
Well, we can both.
Okay, go ahead.
Well, and first of all, farmers are very concerned about if they're losing anything on their farm. There's people out there, as I mentioned a while ago, that want to blame us for a lot of things. But a farmer doesn't want anything leaving his farm. If it's leaving his farm, it's costing him money. We don't, some people, to hear them talk, would think we back fertilizer trucks up and dump them in the road ditch or something. But that's just simply not true, because that's just be costing us money. We're trying to be as efficient and cost effective as we can, and we want every nutrient we put on that crop to be taken up by that crop and used by that crop to produce a crop. So we're very conscious of anything that's leaving our farm, and if it's leaving, we want to know about it. That's why we got involved in Discovery Farms, so if something was going on, we'll find a way to fix it.
And on the fertility end too, there's a lot of technology there. We've gone from, in the past we would just blanket a fertilizer application across that field, to now and we always soil sample before, but now we're soil sampling on grids. So either 2.5 or 1 acre grid, and we're pinpointing where that fertilizer needs to go. So maybe this part of the field needs more fertilizer than this one. Well, when you blanket, you over apply here and under apply here. Well, now we're pinpointing where, okay, we know exactly where the fertilizer needs to go, and the technology and those the trucks that we apply or the airplanes have allowed us to be able to do that. So we've reduced our nutrients that we're applying as well to help reducing those runoffs.
Yeah, and I'll add just a little to that. We have some awesome farmers involved with the program, but it has been my experience that and it just you would think it would go without saying, a farmer's livelihood is their crop, so they want it to be sustainable. So that we are really not seeing what the original computer data that was released based on modeling was showing, that they thought were the nutrients leaving the farms are significantly lower in the delta in Arkansas on the farms that we are monitoring. So we're really not losing a whole lot of nutrients off the farm. Their farmers are doing a pretty good job of applying what the plant needs. Just got a question. Do you guys need any interns?
We're always looking for people.
And what do you think would be the best way to directly support our farmers in Arkansas?
I think things like this, just learning about what we do. You know, a lot of the younger folks are removed from the farm. Maybe their grandparents or great-grandparents had something to do with agriculture, but now they don't. I think a lot of it's just education, and if you read something, do your homework and come ask one of us. I mean, we're happy that we host tours on our farm all the time to try to educate people and just show them what we actually are doing. Like Lori mentioned, and trying to pass these farms on to future generations. So just ask us questions and learn what we're doing. So.
Can I follow up on that?
Absolutely. Yeah.
To follow up on what Trent said, we do a lot of tours on our farm, and we've had a lot of government officials from Washington, D.C. out on our farm. We've had people from EPA, NRCS, USDA, and those people have been really surprised at what we're doing. So like Trent said, it's just an educational process. We just need to get the word out and for more people to understand the technology involved and the things we're doing in conservation practices, things that we're doing, people just don't understand.
So another question from the audience is, has the increased water efficiency decreased the nutrients needed?
Not necessarily. Like I said, we're more just pinpointing where the nutrients need to go. I don't know that we're necessarily, anything with water is causing us to use less nutrients. It's just we're better able to manage things to get the best crop we can get, the most yield.
Another one probably for Ed. So we're pumping water into the bayous, specifically Balamita and tributaries. What are the environmental impacts of adding water to the bayous?
That's been a question for a long time, and back in far back as the 70s, the Soil Conservation Service, now NRCS, looked into that because the river has different nutrients and different minerals in it than the bayous may have in them. So that was studied. We looked at what had to happen before we put the water there and went through a long environmental process of reviewing all the possibilities, and everybody's satisfied that any difference in the quality of the water that goes in the bayou won't be material enough to worry about when you compare it to the issue of the groundwater depletion.
And one last question from our audience, and I think we touched on a little bit in one of the presentations. So compare, the crops can sometimes be shocked from that cold water from the pumped out of the ground versus groundwater versus surface water. Has that been true that you guys have seen any difference in production or crop health based on what your water source is?
Yes, when you're pumping well water, it's usually, as you mentioned, a real cold water as it comes out of the ground, and especially in rice, you'll see a lot of difference between well water and pumping out of a reservoir, because the water in the reservoir has been heated up by the sun, pumping a lot warmer water, and the crops just seem to respond to that a lot better.
Talking about tours and experiences on our farm, many years ago, one of the first verification or research experiments on the farm, Dr. Nathan Slayton with the university did a study on that, and to compare the water from our deep well, from the Sparta well, which is very cold, to the water coming out of our reservoir on the crops. And there was a significant difference, I believe, according to his findings.
All right. Well, with that, we're going to have to wrap it up. We thank you all for joining us. The recordings can be found at the uaex.edu. Thank you for NRCS for funding this, and thank you for the University of Arkansas System Division of Agriculture for producing this program. Thank you.
Thank you for joining us for the Soil and Water Conservation Virtual Field Trip. This broadcast is funded by NRCS and produced by the University of Arkansas System Division of Agriculture Cooperative Extension Service. To find out more about soil and water conservation, visit uaex.edu.